Hello class, this is a video recording of our post-lab discussion for your Module 5, pH-POH buffers. To give you a quick review of the chemical solutions that we made use in our experiment, here is the dish detergent, hydrochloric acid, and then your sodium hydroxide. Lastly is your acetic acid. Now, let's move forward to the data and the results. Sa ating discussion, i-discuss lang natin yung computation on your worksheet and then yung mga na-observe natin na pH and then the classification based doon sa experiment na ginawa natin. Okay? To give you a quick review again of your acid-base strength having your ionization, what do we say about ionization? It is where positive and negative are produced in a dissolved solution. Again, positive and negative are produced in a dissolved solution. So, ito na-discuss na sa inyong laboratory properties. Strong acid, weak acid, strong base, and then your weak base. Next, the acid-base strength. So, meron tayong different categories ng pH range and then meron din silang strength. So, hindi lang sila basta-basta si acid, hindi lang sila basta-basta si neutral, and then hindi lang sila si base. Meron silang differentiation when it comes to their strength. We have the strong, the moderate, the weak. Okay. So, 0 to 2. 0 to 2 is classified. When you observe a pH that is 0 to 2, it will fall under the strong acid category. Okay, next. The 3 to 4 pH will fall under the moderate acid. The 5 to 6 pH will fall under the weak acid. So, itong si 7, ito yung parang pinaka-mark natin or palatandaan natin. Pag 7, neutral. Anything under or anything lower than 7 is considered as acid. Magkakaiba-iba na lang sila or magde-differentiate na lang sila when it comes to their strength. It can be classified as strong, moderate, or weak. Basta, anything under na 7, it will be considered as acidic. Next naman is the numbers or yung mga pH na greater than 7. For example, 8 to 9. It will fall under the weak base. Basic na siya, base. Okay? Yung 10 to 11 naman is considered as moderate base. And then the 12 to 14 will be considered as strong base. Okay, based on the actual results, yung nakita natin or yung na-observe natin sa experiment, ito yung mga apat na chemical solutions na ginamitan natin ng pH meter to know their pH. Okay? Number 1, 0.1 molars of your hydrochloric acid based on our experiment. Ang na-observe natin na pH ni hydrochloric acid using our pH meter is your 1.67 and is classified under strong acid. So, check. Next, 0.1 molar sodium hydroxide. Ang na-observe natin na pH on our experiment is 12.56 and is classified under your strong base. Okay, let us just check. 12.56. Nandito siya between 12 to 14 strong base. Okay, next. Your 0.1 molar of your acetic acid has an observation of 3.32 pH and will fall under the classification of moderate acid or weak acid. Okay? And lastly, your dish detergent having the pH of 8.31 will fall under the weak base or moderate base. So, ito yung mga actual results na observe natin sa ating experiment. And ito yung sagot sa inyong worksheet. Okay? Let us just proceed. In the pH determination, ito mga iba't ibang chemical solutions or reagents na pwede nating mahanap sa laboratory or in our house. So, using the pH meter, we can observe the 0.1 molar sodium chloride will have a pH of 7, which has a neutral classification. Next naman, examples na lang to ha, yung 0.1 molar NH3, meron siyang pH na 10, and is classified under the moderate base. Yung 0.1 NaHCO3 has a pH of 9 and is classified under the weak base. Okay, itong mga light-colored soft drink natin, wala namang binanggit na brand, pero pwede nating itry Next time, pagka meron na tayong face-to-face classes, yung mga light-colored soft drink, meron siyang pH daw na 4. Okay? When we say 4, meron siyang moderate acid or moderate acidic yung light-colored soft drink natin. Okay? And then lastly, your light-colored fruit juice has a pH of 3 or moderate acid. And then next, after we're done discussing the pH determination using your pH meter and then the classification, we will now move forward to the pH as function of concentration. So ito na yung medyo madami-dami na tayong computation tulad nung tinuro ni Ma'am Lina sa discussion sa laboratory ng mga pH, buffer solution. Okay, based on your worksheet, the question number 1 is, based on the recorded pH of 0.1 molar sodium hydroxide in the experiment, calculate for the POH daw. Okay? Hydrogen ion. Let's just classify it under A, yung POH, yung B, hydrogen concentration. And then, we will now discuss your solution. So, importante na bago kayo mag-solve ng ating problem solving, alam mo na dapat kung under ba siya ng acid or ng base para yung formula na ia-apply mo or na isa-substitute mo, hindi ka na magkakamali. So, una pa lang, first step pa lang, dapat alam mo na yung formula na gagamitin. Okay? Letter A. Let's now look for the POH. We will make use of the formula negative log of your OH negative. Next lang, proceed lang tayo. POH is equal to negative log of your 0.1. Ito, given to. Importante din pala na you have your scientific calculator with you on your side para madali na tayo makapag-compute. So, the final result will be 1. The POH will be 1. Okay, apply mo lang sa iyong scientific calculator, negative log times 0.1 is equals to 1. So, our POH is 1. Next, let's now look for the hydrogen ion. Anong formula ang gagamitin natin? Ito po, yung pH plus POH is equals to 14. 14 is a constant. Next, apply lang natin pH plus, yung POH ba nakuha na natin? Opo, nakuha na po natin siya dito. So, i-apply lang natin, isa-substitute lang, pH plus 1 is equals to 14. 14 po kasi constant. Next, yung pH natin, if we will apply the rules of math, if you're looking for the pH, ililipat lang natin yung 1 sa kabila. Pagka nilipat mo siya sa kabila, mababago na yung sign niya. Okay, magiging 14 minus 1 na po siya. Okay, applying the rules of math, 14 minus 1, the pH will be 13. So, ang nakuha na natin mga values is yung pH, which is 1. Next, yung pH natin is 13. Okay, lastly, pH is equals to negative log of your H plus. Again, the pH is 13. Saan natin nakuha to? Dito na po. Is equals to the negative log of your H plus. Ang sabi daw dito, isa-substitute mo lang sa X. Okay, yung 10, di ba yung formula natin? 10 to the exponent of negative 10 is equals to H plus. Yung X natin, which is yung 13, magiging ganito na yung sagot mo. 1 times 10 to the negative 13 is equals to H plus. Okay, so basically, ito lang talaga yung solution natin for your question number 1 on your problem solving with regards to the pH as a function of concentration. Okay, ginawan lang natin siya ng table para mas madaling maintindihan. For example, yung sinolve natin kanina, which is your sodium hydroxide. Kinlassify lang natin siya under the pH, which is 13. Yung nakuha natin. Yung POH niya, which is yung 1, tama, based on our solution. And then, mamaya, i-discuss natin yung theoretical concentration. Pero dito, nakuha lang natin yung pH, POH, yung hydrogen ion niya, and then yung hydroxide ion niya. Pero hindi naman na hiningi ito. So, hanggang hydrogen ion lang yung hiningi. Okay? Going back pala, you can try to solve yung mga iba nating chemical solutions na ginamit on our experiment. On your own, you can practice getting the hydrochloric acid. What if dinagdagan natin siya ng distilled water? Or what if yung hydrochloric acid lang kasi sa worksheet nyo, We only gave 3 questions, pero you can practice that and then try nyo kung magka-come up kayo or mag-a-arrive kayo sa same result that we have in our table. Okay, yung theoretical concentration, i-discuss natin sa susunod na slide. Next, for your question number 2, after the addition of distilled water on your sodium hydroxide solution, theoretically, what is the new concentration of your sodium hydroxide? Sorry, high sodium hydroxide pa, hindi lang na heavy. Okay, again, let me just read the question again. After the addition of the distilled water on your sodium hydroxide solution, theoretically, what is the new concentration of your sodium hydroxide? Again, show your solution. 5 points po siya. So, ilatag lang natin yung mga binigay na given, which is yung based sa observation natin sa experiment, 1 ml nung sodium hydroxide. And then yung 9 ml ng distilled water. So, it will yield a 10 ml solution. So, i-apply lang natin yung ating formula, which is C1 times V1 is equals to C2 tsaka V2. Ano ba yung C1, V1, C2, V2? Initial concentration times the initial volume. Okay? C1. Ano ba dun yung C1? Yung C1 is equals to 0.1 molars of sodium hydroxide. Again, yung C1 mo, yung 0.1 molar sodium hydroxide. Yung V1 mo is your 1 ml. Yung volume 1 mo is 1 ml. Next, yung concentration 2 mo, yun yung missing, yun yung naka-X. Yun yung nawawala. Okay? And then the volume 2 is yung 10 ml natin, which is yung solution mo when you add sodium hydroxide and then your distilled water. Again, do not get confused. Your C1 is your 0.1 molar sodium hydroxide and then the volume 1 is the 1 ml. C1 yan. Yung concentration mo, yun yung nawawala, yun yung naka-X. And then, the volume 2 is your 10 ml. Apply lang natin siya, i-substitute lang natin siya, and you will arrive with the 0.01 molar, which is yung X mo, yung nawawala, yung hinahanap na. Okay? Ni-repeat lang natin yung table na nandoon. So, again, 0.01 yung molar, yung in getting your theoretical concentration. Next, for your question number 3, using the new theoretical concentration of your sodium hydroxide after the addition of distilled water, you have to calculate the pOH. Okay, A lang natin yan. The hydrogen ion. And then you have to show your solution because it will be equivalent to 10 points. Okay, given is that 0.01 molar of sodium hydroxide solution. The pOH, again, the formula, dapat hindi tayo magkamali dito para hindi magdugtong-dugtong yung pagkakamali kasi formula pa lang, mali ka na, magkakamali ka na dun sa mga kasunod. So, pOH is equals to the negative log of, or logarithm of your OH negative. And then next, pOH is equals to the negative log of your 0.01 molar. Okay, substitute mo lang. You will yield a result, or you will arrive with a result of 2. Again, the pOH is 2 using the rules of math or your calculator with you. You will arrive with a result of pOH is equals to 2. Next naman is the pH. Ano yung formula ang gagamitin natin? Again, yung pH plus pOH is equals to 14, which is the constant, yung 14. pH plus 2. Bakit naging 2? Kasi yun yung nakuha nating pOH kanina. Substitute mo lang. Is equals to 14. Again, using the rules of math, ililipat mo yung 2 sa kabila, magiging 14 minus 2 kasi mababago yung sign niya. 14 minus 2 is equals to 12. pH is equals to 12. And then lastly, H plus pH is equals to the negative log of your hydrogen ion. 12 is equals to the negative log of hydrogen ion. Again, yung negative mo na exponent, isa-substitute mo lang yung X, which is yung pH, yung 12. And then you will come up with this one. 1 times 10 to the negative 12 of molar is equals to hydrogen ion. Okay, are we clear on that? Ganun lang, ganun mo lang siya isa-solve. Basta alam mo lang kung ano yung formula na gagamitin mo. and then tama lang yung substitution mo, and then tama yung pagkaka-input mo sa scientific calculator, mag-a-arrive ka sa tamang sagot. Next, let's now move forward to the questions for research. How does a buffer work? Okay, how does a buffer work daw po? A buffer maintains a particular pH when added to the solution. It reacts to any added acid to control pH. It either replaces a strong acid or base with a weak one. Again, a buffer maintains a particular pH when added to the solution. It reacts to any added acid or base to control the pH. It either replaces a strong acid or base with a weak one. So, ito yung example natin. Ang explanation niyan is, since hydronium ion is added, which is an acid, the one that will react in the buffer is the conjugate base. Okay? That's why the reaction would be this one. Okay? Ganun daw po nag-work ang buffer. Next, give examples of buffers in biological systems and describe how these react to pH changes. So, let me just read the answer. The most common buffer is the carbonic or bicarbonate buffer, which found in the blood. Blood contains large amount of carbonic acid, which is a weak acid, and a bicarbonate, which is the base, to maintain the blood pH of 7.35 to 7.45. So, ito, hindi na natin to makakalimutan kasi this is a board exam recall question, and then you will encounter this sa inyong chemistry proper, yung mga clinical chemistry natin. So, dapat ngayon pa lang matandaan na natin at dapat natin isa puso na ang blood pH is between 7.35 to 7.45. So, going back, bicarbonate neutralizes excess acids in the blood, while carbonic acid neutralizes excess base. As a value higher than 7.8 or is lower than 6.8, it can lead to death. So, dapat na-maintain lang siya between 7.35 to 7.45 kasi any value that is higher or lower than 7.35 to 7.45 can lead to death or yung mga complications natin. Okay? Another example ng ating mga biological system buffers is we have your phosphate buffer. We also have your protein buffer and then your hemoglobin buffer. The phosphate buffer acts in a manner similar to the bicarbonate buffer, but has much stronger action. Also, going back, a buffering system consists of a weak acid and its corresponding weak base. An acid is defined as a molecule that releases hydrogen ions in water, and a base is a molecule that accepts hydrogen ions. A weak acid or a weak base ionizes or gives off hydrogen or hydroxyl ions only slight in water, while strong acids and bases ionize almost completely. So, ang buffer, mahalaga siya sa ating biological systems or sa ating katawan. Kasi nga, it maintains yung pH ng ating blood. Katulad nitong si carbonic acid and then yung bicarbonate buffer na very common sa ating biological system. And then lastly, why is acid always added to water and not the reverse? Again, why is acid always added to water and not the reverse? So kung medyo nalilito ka, tandaan mo na ang ating mnemonic pwedeng acid to water. Acid to water, di ba? Kung nalilito ka kung ano ba dapat water to acid or acid to water, meron tayong mnemonic which is parang English ano ka lang nito, taga UK ka lang, acid to water. Okay? Why is acid always added to water and not the reverse? Here is the explanation. A large amount of heat is released when strong acids are mixed with water. Adding more acid releases more heat. If you add water to acid, you form an extremely concentrated solution of acid initially. So much heat is released that the solution may boil very violently, splashing concentrated acid out of the container. So very dangerous daw kapag kainuna mo yung water to acid. If you add acid to water, the solution that form is very dilute and the small amount of heat is release is not enough to vaporize and spatter it. So always acid to water. Add acid to water and not the reverse. So, pagka nagkaroon kayo ng spill on the laboratory or sa may mga encounter kayo na spill in the institution, hospital, or sa bahay, at kapag ginawa mo yung water to acid, it may cause explosion or magkaroon ka ng splashing, di ba, na very dangerous sa iyo. And that concludes our discussion for today. Thank you and God bless.